Hi everyone, welcome back to my channel Pharmagist. Myself Dr. Haimavati. In today's video, we'll be learning about what are prodrugs, what are their advantages and what are the different types of prodrugs. So let's begin our video. Now coming to the prodrug. So this term prodrug was coined by a scientist named Albert in 1958. And coming to the definition, prodrug is a pharmacologically inactive compound that is transformed by the mammalian system into an active substance by either chemical or metabolic means. That means prodrug is an inactive compound. So this inactive compound, when it enters into our body, the enzymes which are present in our body, they act upon this inactive compound and they transform it into an active form. So that is the meaning of a prodrug. So when it is entering into the body, it is in the inactive form. And after the action of the enzymes, so the enzymes which are present in the body, what they do, the foreign compound which is entering into our body, that is the prodrug, they act on this prodrug, and these enzymes, when they act on the prodrug, it gets metabolized into the active form. As a result, the drug is available at the active site. So this is the concept of prodrug. Now coming to the advantages. So what are the advantages of prodrugs? So why we should give the drug in the form of a prodrug? So generally the available drugs, they have a number of disadvantages. So in order to overcome those disadvantages, we can formulate the drugs into a prodrug form. For example, in order to improve the organoleptic properties. So if you want to improve the organoleptic properties. For example, we have a drug called chloramphenicol. So this chloramphenicol has a bitter taste. So in order to mask this bitter taste, what we can do, if you convert it into a palmitate form. So the chloramphenicol palmitate, it masks the bitter taste. As a result, the drug will not be bitter. So when you're taking it, you won't get the bitter taste. So as a result, you can improve the organoleptic properties. Next, increase the bioavailability. So you can also increase the bioavailability of a drug. For example, ampicillin has less bioavailability. So when you formulate it in the form of pivampicillin, this pivampicillin is an ester form of ampicillin. So as a result, what happens? It becomes more lipid soluble and more efficiently absorbed than the parent compound ampicillin. Next, we can also use this prodrug concept in order to improve the stability of the drugs. For example, azacitidine. So this azacitidine, it gets hydrolyzed in the body because of the acidic pH. And when you convert it into a bisulfide prodrug form, what happens? It becomes stable to the acidic pH. So as a result, it will not be hydrolyzed and it will be more available in the body. So as a result, you can also improve the stability of the drugs. Next, we can also use these prodrugs to reduce the gastric irritation. For example, salicylic acid, because it is an acid, what happens? It causes gastric irritation when you give it directly. So if you formulate in the form of an aspirin, so aspirin is the prodrug of salicylic acid. So as a result, what happens? The gastric irritation is reduced. And next, you can use it to reduce the pain at the site of administration also. So most of the drugs, they are weakly acidic in nature or having poor solubility. So because of this weak acidic nature and pure solubility, what happens? They cause pain at the site of administration. So if you can use this prodrug concept in order to reduce this acidic nature and solubility problem, you can reduce the pain while giving an injection. Next is increasing drug solubility and dissolution rate. So Salindac is a prodrug of salindac sulfide, which is more water soluble and hence it is available for oral absorption. So this Salindac, because it is more water soluble, so when you give it in the form of an oral dosage form, it will be more available and compared to the salindac sulfide, which is less soluble. So as a result, you can increase the drug solubility dissolution rate and it is becomes more available at the site of action. And we can use this prodrug concept in order to prevent pre-systemic metabolism also. So some drugs which when they are entering into the body, they are metabolized. As a result, what happens? The concentration of the drug which is available at the site of action is reduced. So when you convert them into this prodrug, for example, we have this propranolol. So propranolol, if you formulate in the propranolol hemisuccinate, it gets metabolized into the active form, that is propranolol. So as a result, we can avoid pre-systemic metabolism. Next, dopamine. So dopamine also, if you give in the form of L-dopa, it gets metabolized to dopamine. As a result, you can overcome the pre-systemic metabolism of this drug. Next, we can also use this to prolong the duration of action. So some drugs, they have very short life. So because of this short life, what happens? You need to give them more number of times, that is the frequent dosing. So in order to maintain the adequate plasma concentration. So for this, what you can do, if you can formulate in the form of a prodrug and you can control the release of the drug from when you can control the release of the drug, so you can also increase the half-life of the drug. As a result, what happens? We can maintain the adequate plasma concentration at the site of action. For example, fluphenazine deconate. So this fluphenazine deconate, it gets metabolized to fluphenazine, and estradiol propionate, it is converted into estradiol. Next, coming to the types of prodrugs. So we have two types of prodrugs. They are carrier linked prodrugs and bioprecursor prodrugs. Now let us see what are carrier linked prodrugs. So in carrier linked prodrugs, the drug is covalently attached to a pro-moiety. So this pro-moiety is an inactive form of the drug which is covalently attached to the active drug. So when this enters into the body and when it passes through the cell membranes, what happens? The enzymes which are present in the body, they act upon this and they break this covalent bond between the drug and pro-moiety. As a result, the pro-moiety is liberated from the drug and the active drug is available at the site of action. So this is the concept of carrier linked prodrug. So enalapril is the monoethyl ester of enalaprilat and pivampicillin is the ester of ampicillin. So these two are examples for carrier linked prodrugs. And this pro-moiety is not necessary for activity, but it gives the desirable property to the drug, that is either the stability or increased absorption or whatever. So the advantage of formulating a drug in the form of carrier linked prodrug is either there is increased lipid or water solubility and site directed delivery, that is the drug is available at the site of action. Next, we have bioprecursor prodrugs. So these bioprecursor prodrugs, they do not contain any carrier or pro-moiety, but they are metabolically or chemically transformed into the active drug. That means the drug is in the inactive form, and when it enters into the body, it is by the action of the enzymes or chemical reactions converted into an active form. For example, cyclophosphamide. This cyclophosphamide is inactive, but when it enters into the body, the liver, the enzymes which are present in the liver, they act upon this cyclophosphamide and convert it into phosphoramide mustard, which is the active form of the drug. Next, we have another concept known as drug latentiation. So drug latentiation, it was introduced by Harper in 1959. So it refers to the drugs that are specifically designed to require bioactivation. So drug latentiation is different from the concept of prodrugs. Here what it says is these drugs, they require bioactivation. So whenever they are entering into the body, they need to be attacked by the enzymes which are present in the body so that they are converted into the active form. And next we have another concept known as hard drug. So hard drugs are compounds that are designed to contain the structural characteristics necessary for pharmacological activity in a form that is not susceptible to metabolic or chemical transformation. That means these are the compounds so whenever they are entering into the body, what happens is they are not prone to the attack by the metabolic enzymes which are present in the body. So that is the hard drug. When you're taking it in the body, the metabolic enzymes, what they do, so their property is to act upon the foreign body which is entering into the body. So when they act on the hard drug, what happens, this hard drug, it does not undergo any reaction because of the attack of these metabolic enzymes. So as a result, what happens, there is no production of any toxic metabolite, and the efficiency or the efficacy of the drug is also high because it is not undergoing any chemical reaction with the enzymes. It will only show its pharmacological activity and it will not produce any toxic metabolite. And next, another concept is soft drug. So soft drugs are compounds that are, after exerting their desired pharmacological effect, they undergo metabolic inactivation to give a non-toxic product. That means these soft drugs, when you're taking it, what happens? The enzymes in the body, they attack these soft drugs. After they attack the soft drug, what happens? The products which are formed are non-toxic in nature. So because they are non-toxic, there won't be any side effect on the body. So we can also consider these soft drugs as an opposite form of prodrugs. So this is about the different concepts of prodrug, hard drug, soft drug and drug latentiation. I hope the video was informative. So if you like the video, do not forget to like, share and subscribe to my channel. See you in the next one.